So in this class we are going to deal with how to formulate LPP. Right? How to formulate the LPP. There are two steps to formulate the LPP. The first one is mathematical formulation and second one is general formulation. So there are two things in formulating LPP. The first one is mathematical formulation, whereas the second one is general formulation of LPP. So we will deal with the first one, that is mathematical formulation of LPP. So it contains the following steps. Fine. The mathematical formulation of LPP contains the following steps. That is step number 1. What it contains. So step number 1 contains to write down the decision variables of the problem. So first of all, we have to suppose to write the decision variables of the problem. Fine. Write down the decision variables of the problem. Fine. Then comes to the step 2 here. To formulate the objective function, once we have finished with the step 1, that is writing down the decision variables, in step 2 we need to formulate the objective function. So formulate the objective function. So how to formulate the objective function? So objective function can be maximized or minimized according to the need. Fine. If it is in case of a profit, or in case of a sales, we need maximized sale or maximum sale. If it is in case of resource allocation, then loss, we need to minimize the objective function. These are the small examples that I have given. Fine. So we need to formulate the objective function, whether it will be maximized or minimized depends upon the need. Fine. So as a linear function, of decision variables. So let us have a relationship between step 1 and step 2. First of all, in step 1 we deal with the, we prepare or we write down the decision variables. Then we prepare objective function, whether it is to be minimized or maximized, as a linear function of these decision variables. Whereas step 3, to formulate other conditions, that's called as constraints, I will say. To formulate other conditions. Such as resource limitation, then comes next market constraint, then comes interrelations, between variables, etc. So these are all called as restrictions or constraints. Fine. With respect to the linear function. So in step 1 we run the decision variable and we are going to prepare objective function in second step, whether it is to maximize or minimize with respect to these decision variables, and we need to formulate the other conditions. So other conditions means restrictions or constraints such as resource limitations, market constraints, relation between variables. Whereas in step 4, to add non-negative constraints, to add non-negative constraints from the constraints, so that negative constraints of decision variables do not affect the solution. So let me explain this one. To add non-negative constraints. So there are some constraints, they are negative, and in further results they are going to affect the solution. Fine. So that's why we are supposed to add in mathematical formulation of LPP non-negative constraints. Adding is very important, so that these negative constraints of decision variable should not affect the solution. Fine. So these are the 4 steps of mathematical formulation of LPP. These are the 4 steps of mathematical formulation of LPP. Fine. So next thing is, let me rub this one. Let me rub this one. Fine. The second one is general formulation of LPP. So what happens in general formulation of LPP? So in order to find values of n decision variables, that is x1, x2, x3 up to xn, whether it is to be maximized or minimized the objective function. Fine. So in order to find the value of n decision variables, whether it is to be maximized or minimized the objective function, that is z is equal to c1 x1 plus c2 x2 plus c3 x3 plus and so on up to cn xn. This is what equation number 1. Fine. And also satisfy m constraints. Fine. This is general formulation of LPP. A11 x1 plus A12 x2 plus A13 x3 up to A1 n xn, that is B1, and A21 x1, A22 x2, A23 x3 up to A2n xn in bracket greater than or equal to, less than or equal to, then greater than or equal to B2, and so on and so on and so on. Fine. Fine. It is AM 1x1 plus am2x2 plus am3x3 up to amnxn, that is less than or equal to greater than or equal to bn. And this is equation number 2. Fine. This is equation number